Recording. Good morning again, grade 7. Okay. We are done with opaque object the last time we had the discussion. Let's move now to transparent and translucent objects. So what's with the transparent and translucent objects? If you look at the white light bulb to a filter of red plastic wrap, if you're gonna wrap the white bulb, only red wavelengths are transmitted to the plastic. The red plastic absorbs other wavelengths. Therefore, the light bulb appears to be red. So if you're going to look at it, it is actually the white bulb there is transparent, okay? Because of this transparency, you can actually see the white color because it's white, right? Again, the implication that it looks like white, it is simply because it reflects all the colors of the Roy G wave. That is actually the reason why it appears white. Okay? And we covered it with red. So once we covered it with red, it will become translucent. Why? Because all the colors are actually absorbed except for the red. Okay? The red now, the one that we actually see is the reflection of the colors it actually emits. Like the tint. The tint actually, it's an opaque object. Why? It actually covers the entire color and just, okay, it just reflects a minimal or very, very low amount of light. Interaction of sunlight and matter. So how could this have an effect in an environment at the same time in us? Have you ever wondered why sky is blue? What do you think so? What do you think the sky is blue? Or the sun is yellow? The interaction of light and matter causes interesting effects, such as these sunlight travels through the air. Okay, let's take a look at why. Scattering of light. As sunlight moves through Earth's atmosphere, okay, most of the light reaches on the ground. However, blue wavelengths are shorter. They are actually shorter than red wavelengths. The particles that make up the air scatter, okay, the blue or the shorter blue wavelengths more than the scattering of long wavelengths. Okay, the sky appears blue because number one, the blue wavelength spreads out in every direction. That is actually what makes it blue. Okay, then eventually they reach eye in all parts of the sky. Okay, as the source of light, as light as a source, okay, such as sun, light emits all colors of light. Okay, it emits all the colors of light and should appear white. If again, as what I'm telling you a while ago, if you actually saw white light, therefore it emits all the colors. After blue wavelengths of light scatter, the remaining colors appear yellow. Okay, vision and the eye. Light enables object to be seen, of course, because again, even in photography is light. Without light, there is no photography at all, or there's no pictures, or we cannot see anything. Okay, light from the luminous object travels directly from the object to the viewer. Okay, objects are also seen when they reflect light in our eyes. Colors, as we can always observe, colors is a reflection of light in our eyes. Okay, again, without light, there is no, you cannot actually see any color at all. Sound. Sounds are type of wave that can be heard. Okay, because we have audible, we have audio in our ears, we have sensors in our ears that can actually absorb this wavelength, sound waves. Sounds are longitudinal mechanical wave, meaning to say if it is mechanical, it needs a medium in order for it to travel. Unlike light waves, sound waves must travel through a medium or to something. Okay, audible vibration. Sound waves are vibration that ear can actually detect. Okay, healthy young humans can hear sound waves produced with vibrations with frequency between 20 hertz and 20,000 hertz. Sounds with frequencies below 20 hertz are called infrasonic waves. Okay, Above 20,000 hertz are ultrasonic waves, infra and ultra. Okay? Compressions and refractions. What's with the compressions and refractions with sound waves? Sound waves usually travels to ears through air. Okay? Air particles are in constant motion. As particles bounces off or bounce off objects, they exert a force or a pressure. Okay? Suppose a pluck of guitar string, or you suppose you pluck a guitar string. Okay? As the string springs back, it pushes air particles forward. Okay? Forcing them closer together. As this increase, the air pressure near the string. Okay? A compression is a region of longitudinal wave where particles of the medium are closest together. Okay? As string vibrates, it moves in other direction. This leaves behind a region where lower pressure. Okay? There is a higher pressure and there is a lower pressure. A rarefaction is a region of longitudinal wave where particles are farthest apart. Okay? If a longitudinal section where particles of a medium are closest, if they are actually close, it is considered as compression, compressed. Okay? If a region of longitudinal wave where particles are farthest apart, if they are apart, it is rarefaction. Okay? Compression and rarefaction. So this is now the what? The illustration of compression. As you can see, this is actually what? A wave traveling, longitudinal wave, okay, traveling. This is the compression area here, wherein the particles are actually what? Actually close to one another. Okay, this is compression. And areas with particles apart, okay, when they are far apart with each other, is considered rarefaction. So this is rarefaction. Okay. Properties of sound waves. Sound wave is described by its wavelength, frequency, amplitude, and speed. Okay. These properties of sound waves depend on the compression and rarefaction of sound waves. So let's take a look at wavelength, frequency, and pitch. Okay. The perception on how high or low the sound seems is called pitch. If it is high or low. So how can we detect high and low? The higher the frequency, the higher the pitch of the sound. So it is based on the frequency. Amplitude and energy. You use more energy to shout than to whisper. Why do you think so? Okay, the more energy you put into your voice, same as what I am doing now, the farther the particles of air moves as they vibrate. Okay, the distance of vibrating particles moves from its rest position from 0 is the amplitude. Okay, the distance of vibrating particles moves from its rest position from 0 is considered as amplitude. Okay, the more energy used to produce sound wave, the greater the amplitude is. Okay, speed. Sound waves travel much slower than electromagnetic waves, of course, because it needs a medium in order for it to travel, correct? The type of medium and temperature affect the speed of sound. Okay, type of medium. This is in particular with sound waves. Gas particles are far apart and collide less often than particles of the liquid or solid. As gas takes longer to transfer sound energy between particles because, again, their molecules are far from each other. Okay, they're less to collide. Temperature. Particles move faster and collide more often as the temperature of gas increases. So this increase in number of collision transfers more energy in less time. Temperature has the opposite effect on liquids and sound. Okay, as liquids and solids cools, the molecules move faster or move closer together. They collide more often and the transfer of energy is faster. If, again, the molecules are intact or together. Intensity and loudness. What's with the intensity and loudness? Do you have any questions so far? Are you still with me?
Yes.
Okay. Again, intensity and loudness. Generally, the greater the amplitude of a sound wave, the louder the sound seems. As you move away, the wave's amplitude decreases and the sound seems quieter. This is because as sound wave moves farther from the source, more and more particles collide and the energy from the wave spreads out among the particle or particles. Therefore, the farther you are from the source, the less energy present in the same area of space. So again, because it interacts with another matter. Recall that the amount of energy that passes through a square meter of space in 1 second is the intensity of the wave. Loudness is your ear's perception of intensity. Hold on. Let me check on this for a while. Okay, going back to the discussion, the decibel scale. So this is how we actually what gauge, okay, the intensity or loudness of what of sound. Okay, the unit used to measure sound intensity or loudness is the decibel or dB. Okay, as the decibel level goes up, the amount of time you can listen to the sound without risking hearing loss gets shorter and shorter. People who work around with loud sounds wear protective hearing devices to present hearing loss. Okay, this is now the decibel scale. Okay, as you can see, okay, the bigger the decibel, okay, the louder it is actually. Okay, the smaller the decibel, okay, the safer it is in your ears, of course. Okay, this is the decibel scale. Okay. Do you have any questions so far?
No.
Okay, we are done with the discussion. We are done with our module for the second module of the third quarter, um, which is actually the coverage also for your third periodical tests. Your third periodical test is fast approaching. So what are the coverage? The coverage here is from your mastery test, your module 1, weeks 1 to 4, of course, and the second module, which is weeks 5 to 8. Okay. We are done with this. Waves, light, and sound. Expect for a series of activity by next meeting. Okay, same as your computer 7. Questions before we go?
No.
Questions before we go? How about others? All right. I'll be uploading this one again in your LMS so that you can review on what we had discussed. Okay. Inform your classmates that I'll be opening activities by next meeting. All right. I think that's all for today, class. Thank you for your participation. Grade 7. Have a nice day, everyone. Take care. Bye-bye.
Bye.